Hello and welcome back to the workshop. If you saw my last video, then you'll recognise the innards of this machine as being the US model BBC Micro converted back to UK spec. There's a little bit of history about how these machines came to be in the other video, so you might want to watch that first. You don't need to watch all of the technical circuit discussion, but be aware that I've created my own schematic for this board because there wasn't one in existence. You can download that from the channel website. I had this machine running for about 2 hours and I began to think it was okay. And then there was a loud bang and a flash and the whole thing shut off. So we have the typical refurb explosion, and therefore the first job to do will be to recap the power supply. We have to disconnect some wires, undo some screws and push the power outlet back into the case. Then the circuit board can just be slid out. From this camera angle I can't really show you much detail, so we'll speed on through this. Here I'm trying to unplug the spade connectors on the back of the power switch. It's quite a stretch because there's not a lot of room for manoeuvre in here. Here I'm trying to free up the latches on the power outlet so that I can push that back through the metal case. That should free up everything so I can dismantle it properly. Turned out it was the cable ties behind that connector that were stopping everything moving. Now I'm cutting those and everything will be freed up. Well, now that we can see the circuit board, we can have a look at what's gone wrong. Straight away, you can see the fuse has blown, and next to it, this refurb cap has exploded. There's a second refurb cap just up here, and although it's intact, we're going to change that too. And also, there's a startup capacitor, which is over here, and that will be changed as well. The parts we're using were supplied by Retro Clinic. In this case I ordered the basic kit, which has just 3 components, but I recommend buying the full kit. It's only a few pounds more and it covers all of the problem capacitors in the power supply, and it may well save you having to redo the job again at a later date. The kit comes with instructions and clear pictures of the various PSUs in circulation. Ours is the one on the left. The first one I'm doing is the reset capacitor. It's a slightly different size from the original, but it fits just fine. It is polarised, so it has to go back the right way round. Next is the bigger of the two reefers. Looks identical to the original except for the colour. And finally the small reefer. This is the one that exploded. Again, the new one is exactly the same size as the old. I'm doing a quick clean up on the board to clean away the debris from the explosion, but other than that it's just a straight case of soldering it in. With a new fuse in place, it's all done, so let's rebuild this thing and get it tested. So the 5-volt rail is giving us 5.1, and the negative rail is giving us minus 4.1. I know it's not minus 5, that is a bit off. That may be good enough to run the audio though, which is all it's for. I know there's some Reconnect stuff, but I'm never going to use that. Let's just check this separate connector here. 0, 0. 11.6, not 12, but it's not bad. 5.1. Well, the good news is it's working. So, first things first, let's see if it works. And the first thing you find is that these connectors at the back, which if you look at the original Beeb, these things are fitted onto the circuit board. In this case, they're fitted to the back case or to the metal shield, and then the wires are soldered down. And that means that the angle at which these sockets face is not the same as it was in the original. Slightly twisted to the left. Just makes connecting a little bit more difficult. Okay. Yeah, as I expected, we're not getting a power up. So that's one of the things I need to have a look at and try and understand why. It doesn't appear to be a permanent fault. It comes and goes. Here's something I want to look at. This is the way it came to me. This is the reset circuit, and the capacitors around that chip have been changed. Ah! Magic. So all I've done there is fiddle around with the keyboard connector, so it's possible we've got a problem there. So now I need to get the PCB out of the case. It's sitting in a metal tray, and getting that out in one piece is a bit of a struggle. As you'll see later, it is possible to remove the PCB first and then the metalwork. It's your choice. Finally. What's interesting here is the whole thing came out without all that nonsense with desoldering wires and undoing screws. but I'm going to have to undo the screws here in order to lift the board out. One export board with some mods. So I think it's time to clean up the board, fix up the caps on this side. I want to put those yellow caps into the board properly, get them secured. So all of these little link pins need removing and cleaning, all the socketed ICs need to come out, and these keyboard connectors, and we know we've got a keyboard problem, so I'm going to have to clean those up and also check and reflow the solder joints on the other side to make sure that connector's good. But I think I'm going to do the keyboard first, because what's left to do on that is probably going to be a quicker job. So I'll put this to one side. Now the first thing you notice with this one is it's quite clean. It's also complete with the never needed sockets for the speech extension. But something else, I don't know whether you've noticed this yet, but if you take a look at this end key, you'll see it's not aligned the same as all the others. In fact, it's not the right key, it's off a different keyboard. So that needs to come off and get replaced. Now luckily, I had a rummage on eBay and I found a seller who was breaking down keyboards and selling the bits as spares, and I managed to get myself a right arrow key. Seems to be intact. A few marks on it from normal use, but that'll do. So, first job of the day. And yes, I did get myself one of these. It's fine. It's certainly good enough not to be picked up as a problem, unlike this one. Well, if anyone needs a spare key, I'll hang on to it. Let's strip it down. Incidentally, I've seen people using these keyboard pullers, keycap pullers, and some people use them straight on like that, horizontally or vertically, and others he said, making a complete hash of the whole job, others use them diagonally, you see, like that, so you're actually picking up the corners. And I've just been experimenting with doing it both ways, and it is easier to pull the cap off when you do it diagonally. The only issue is once you've got the key in that state, it can be a bit difficult to twist it out of the pullers. The amount of force needed to pull that straight up is quite significant. And if I turn it sideways on, it's because you're pulling on the corners. That felt easier. There are some markings on here. Solder's been reflowed on that brake switch. Switch itself has got some damage. Could be the switch has been desoldered and resoldered in and it was somehow broken when it came out. Again, could have been me, I have no recollection. There's also a little mark over here on the keyboard connector. I don't know. Oh, is that not R? Sideways. That would be not reset. Clearly there was a problem in the past. But anyway, it seems clean enough. I don't believe I want to spray any contact cleaner into the switches because it all seemed to be working earlier on. So I think I'm just going to do a clean-up job and check out soldering on the keyboard connector itself. And then apart from I'll check the LED soldering as well because those things always go. Reason being is these protrude from the case, so you tend to rest your wrist on them and push them in. So I'll check those. Oh, and look, the startup dip switch appears to have had some wires soldered it at one time, and which have now been removed. I think I should put a proper switch in there just like I did with the other spare keyboard. Alright, a nice neat row of switches. far better. Now I'm just going to check out the solder joints down here. Alright, I think functionally that's fine. Alright, I think our keyboard is complete. So now moving on to the main board. So I think I'm going to remove the makeshift sideways RAM upgrade just for the moment, so that it's out of the way. So I think the first thing I want to do is a clean up with isopropyl on this end of the board, because this seems to be mucky. And once I've done that, I'll look at the other items. I'm going to work on this bit next. This is odd because the 555 timer, which is the reset circuit, has been socketed, and to do that you'd have had to take the board right out of the case. In fact, I can see signs of soldering going on under there. And yet these capacitors, I don't know, it looks as though the original caps have been cut off and these have been tacked on as if to avoid taking the board out of the case. Maybe whoever worked on it last was tired of stripping it down. So I think what I'm going to do, there's nothing wrong with these capacitors and the lead spacings are fine, so I'm going to take these off and fix them properly into the board, just so they're not flapping about like this. there it is. Much neater. Good. Now I noticed while I was doing this potentiometer here is sitting at a slight angle. So I'm just going to put a bit of heat on the pins and I'm going to push that back down to try and make it stay in a better position. There we go, that looks straighter. Okay, so keyboard connector was the next thing to look at. Again, it's hard to see whether there's any problem on there, but I'm just going to solder those pins in a little bit more solidly than they were. Alright, so now going to remove all the socketed ICs, clean the pins, put some contact cleaner down in the sockets, replace them. I particularly want to clean the pins on the keyboard socket, and I may just have a look at all these jumper settings as well and clean those. So that's clean. Note that many of these sockets are single wipe and the wipe is on the inside. That means that the contact is happening here on this edge of the pins and here. So you have to clean the inside of the legs more thoroughly than anything else. Now removing every IC, cleaning it up, putting it back in the socket, and the same thing with the links, took me just over an hour. And rather than bore you with all of that, we're going to skip ahead to the next bit. So I've cleaned everything, got some contact cleaner in to all these little links. I've had a go at these connectors on the back and on the front. So I think it's as good as it can be, and I'm going to now plug in the keyboard and the power supply and a monitor cable and see if we can get anything out of it. Here it goes. Work first time. Ah, now, do we get a picture? So we have, that's interesting, a Solidus DFS. I assumed I'd have had an Acorn one in there. I have no idea what ROMs are in this this machine, but hey, it's working. Sounds like we're not reading the speech ROM properly. Off camera I swapped in the PH ROM from my other Beeb and it worked fine. So it looks like, unfortunately, the chip in this computer has failed. I'll have to look for a spare, but I know they're difficult to find. My S key is out of position. That's better. Well, yes, here we are again. It seems that my belief that the keyboard cable was the cause of the problems I was having with this board were incorrect, because it started doing it again the minute I began to rely on it. But I have found that if I poke about down here by the reset circuit, I get resets. Resets I shouldn't be getting. And sometimes if I poke about for long enough, it stays in a reset or stuck state. So I think that what was happening was the keyboard cable, which is here, was pushing down on the board, and it was flexing nearby the reset circuit, which was enough to change the situation. So simply pushing down on the cable would have probably done the same thing. So I have a problem around here, and obviously somebody before me had a problem around here because of all this nonsense with the capacitors and the fact that the 555 timer is socketed. So given all that, I think I'm going to have a close inspection under the microscope just to look to see if I can see any broken traces, maybe near the vias, and if I can't see anything, I will remove all of those components. So those yellow caps are going again, the socketed IC, and there must be one or two other components there. Anything to do with the reset circuit I'm taking out and cleaning up, inspecting, and hopefully in all of that I'll find something. I don't know how well you can make this out. There we go. Now, you see that solder joint dead center of the screen? That is a classic dry joint. The solder's slumped around the pin and not properly connected with it. And I suspect that that pin is sliding up and down in that piece of solder whenever I push down on it from above. That may be the cause of the problem. But you know, I hate the look of that socket so much, I think I'm just going to take that socket out, put a fresh one in, and with a bit of luck, that'll fix the problem. This socket was really obstinate. It is only 8 pins after all. In the end I had to resort to the hot air gun. Well, I was thinking of putting a brand new 555 timer in, but I think now I've found that dry joint, I think that's probably going to be the answer. So I'm going to clean up the legs on the old one, And if the problem doesn't go away, then I will change the chip. Okay. I've got more work to do, because what I was trying to do before I ran into all those troubles with the reset was evaluate what's going on with the ROMs, and I had all these ROMs programmed up with test images, just anything that would work, so that I could prove by changing all the links exactly what I thought would happen. And pretty much everything that I thought would happen happened, except with that socket. And there are actually two problems with that socket. The first one is a design fault, and the second is these crappy sockets that only have contacts on one edge. I'm finding that I have to actually curl the legs of the chip that goes in that socket inwards to get them to make contact. So I think I'm going to do what I did to the other beep. I'm going to get out some new sockets that are far better than these, and I'm going to change them out. Right, 5 brand new sockets, and I'm just going to look at those solder joints under the microscope to check that I've not made any stupid mistakes, and then I can put the chips back. Power on, straight back up. Bit of interference on the screen, that's just our RGB lead. X12 basic editor, Sleuth Etiquette, Toolkit Plus. Of course we've got OS 1.2 and we've got basic because I've got the prompt. Yeah. Alright, so every one of those ICs is responding. And I think I'm ready at last to finish my research on what goes on with all these links and what these ROM sockets can do. Putting that aside, let's take a look at the outer casing and see what it takes to clean it up. This is the inner metal tray. Not quite sure what that piece of sellotape's for. But I don't think, other than a basic wipeout, I'm going to do very much with this at all. I think that's all just fine. This bottom piece of metal, I mean, I know I don't have a complete case here because I don't have the external pieces of metal, but judging by the state of this one, I think they would have all been pretty tarnished and rusted by now. So, lessons learned from the previous beeb. This plastic strip is going to get cleaned with nothing more than washing up liquid. I'm not going anywhere near that logo. I'll be back. There we go, cleaned up and no disasters. Putting that to one side. I don't know whether it's possible to do anything about this tarnishing. I think I'll give that a quick go, and then I'll come back and look at the plastics. Well, I tried various cleaning solutions and that wouldn't touch it. In the end, metal polish, and it's come up like this. I think that's pretty good, much better than it was. So that's the one metal plate dealt with. Now on to the plastics. I've got to say, now that I have this in the daylight, I'm not seeing any yellowing problem. This thing was just incredibly dirty. And you can see generally that the colour of the back and the front is almost the same, the inside and the outside. Usually you can get an indication from the stuff that's not been in the sunlight as to where there might be a colour difference, but I'm not really seeing enough to make me concerned about wanting a retro bright, so I'm going to leave it. Note the two brass standoffs here. They were originally to support the top half of the RF shield. I think the shorter one goes at the front. There's a minor alignment problem here with the PSU screws, one of them won't go in. I'll fix that later. Okay. Yep, looks like all the ROMs are up. Good. Right, here we go. Excellent. Right, let's see if we can boot Elite. Well, that seemed good. Yep. Alright. And so, while I continue with my kamikaze docking in Elite, there's not much more to do other than to fetch some games and do some more unskilled playtesting. Since the last work I did on the reset circuit, the computer has been rock solid. Looks like whoever made the attempt to fix the original fault managed to introduce a new one of their own, but fingers crossed I'm finally done with it. Also, my ROM investigations are complete, and I'll push out another video to update you on that, as this one is too long already. Plus, I might do another one on retrobrighting the plastic case on the floppy disk drive which was supplied with this computer. Once again, thanks for watching, and I'll see you next time.